Hello everyone, I am Shivam Pasari and welcome to ASN Academy. So as you can see from the title of this video, in this video we'll solve another very interesting question on the topic of number system, and this is an expert level question. Now the question is as follows: n is equal to 70 factorial into 69 factorial into 68 factorial all the way up to 3 factorial into 2 factorial into 1 factorial. Which of the following represents the 147th digit from the right end of n? Now we are provided 4 options for this question: option A 2, option B 0, option C 5 and option D 7. So this was our question on the topic of number system, and I would like you to try this question first by yourself and then come to this video for the solution. I hope that I've tried the question and you've got the solution, and if you didn't, then let's check the solution. So according to our given question, we are given a number n such that n is equal to 70 factorial into 69 factorial into 68 factorial all the way up to 3 factorial into 2 factorial into 1 factorial. Now this is our given number n. Now according to our given question, we have to find the 147 digit from the right end of n. So let's say the starting numbers of the number are 2, 3, 7, 8 all the way up to 0, because the last digit is definitely 0. Now we have to find the 147 digit from the right end of n. So over here we will have 146 digit and we have to find this 147th digit. Now since we have an option 0 in our question, first let us check that whether the 147 digit of the number is 0 itself only, because the numbers 70 factorial, 69 factorial, 68 factorial, all of them have many trailing zeros. So if we have so many large numbers and so many trailing zeros, then there is a high possibility that the 147 digit is a 0. So let's find whether the last digit is 0 or not. So let's check how many trailing zeros each factorial has. So from 1 factorial up to 4 factorial, there are no trailing zeros. So in total we have 0 zeros. Now from 5 factorial up to 9 factorial, each of the factorial has one trailing zero, because 5 factorial is 120, 6 factorial is 720, and so on and so forth. So we have one trailing zeros. So in total these 5 factorials has 1 0. So we have 5 zeros. Now from 10 factorial up to 14 factorial, we'll get 2 trailing zeros, because from 10 factorial we'll have 2 powers of 5. So 2 into 5 is equal to 10. So in total we have 10 trailing zeros. Now from 15 factorial up to 19 factorial, we'll get 3 trailing zeros. So 3 into 5 is equal to 15. Now from 20 factorial up to 24 factorial, we'll have 4 into 5 trailing zeros. So we'll get 20 trailing zeros. Now moving to 25 factorial up to 29 factorial, each of these factorials will not have 5 trailing zeros but 6 trailing zeros, because from 25 factorial we'll get another extra power of 5. So we have 6 into 5 trailing zeros in each of these 5 factorials. So you'll get 30 trailing zeros. So you can see a pattern. We have 0, 1, 2, 3, 4, then 6. So the next number is definitely 7. So from 30 factorial up to 34 factorial, we'll get 7 trailing zeros. So 7 into 5 is 35. Now moving on to 35 factorial to 39 factorial, we'll get 8 trailing zeros. So 8 into 5 is equal to 40. So let's count that till here how many trailing zeros we have. So 5 plus 10, 15, 15 plus 15, 30, 30 plus 20, 50, 50 plus 30, 80, 80 plus 75 is equal to 155 trailing zeros. So till here only, so from 1 factorial to 39 factorial, we have got 155 trailing zeros. So we can say for sure that the 147 digit from the right has to be a 0, because we have at least 155 trailing zeros. So we can say that our answer is option number B, 0. So in questions like this, first check that whether the last number or the number that we have to calculate is 0 or not. So if it is 0, our task is very easy. So our final answer is 0.